Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another video. Awesome. So how to recognize periodic trends of groups and valence electrons worksheet. So we're going to carry on through this one here. It should be a really good video. Lots of information on this one here. So here we go. I'm going to be reading through some of this material here, and then you're just going to follow along. We already have read this periodic trends and how awesome and cool the periodic table is. So we're going to focus on some other sections here, right over here. Number one, the primary level of organization of the periodic table is the atomic number, which is a representation of the number of protons in an element. So the primary level of organization is the atomic number. Okay. All right. That is, hydrogen is the first element having one proton with an atomic number of 1. This is why hydrogen is the first element on the periodic table. The second element is helium, having 2 protons with an atomic number of 2. This is why helium is the second element on the periodic table. This trend continues with the third element of lithium having 3 protons with the same atomic number, and that would be 3. Okay, so let's just point this out on our periodic table and to make sure that you understand this, if that would be fantastic. Hold on just a moment. All right, so now we're going to pull out a periodic table here so I can show you this principal or primary level of organization. This is the periodic table that I use for my general chemistry class. So atomic number 1, hydrogen, 2, helium, 3, lithium, and let's continue on here. 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, etc. Right? It even continues, like, for example, 54, 55, 56, 57, 58 through 71, and then 72, etc., all the way to 80, and then all the way to 86, and it keeps on continuing. So this is a thing of beauty how the periodic table is organized. All right. Awesome. Now that we got that, so the primary level of organization on the periodic table is the atomic number of protons. Number 2, the next 2 levels of organization are vertical columns and horizontal rows. The vertical columns are called groups or families. The vertical columns are called groups or families because they all have trends in common, just like a group or a family has common characteristics together. The groups are labeled from the left to the right, with the first left-hand group labeled as group 1, with the element hydrogen at the top of the group. The second group is labeled as group 2, with the element beryllium at the top of the group. This trend continues as one moves to the right along the periodic table. And an additional feature of each group is that the group number corresponds to the number of valence electrons. Therefore, all elements in group 1 have 1 valence electron, and all elements in group 2 have 2 valence electrons. The valence electrons are the outermost electrons that are available for... Wait a second. I'm missing some of this. I apologize for that. Okay, an additional feature of each group is that the corresponding to the number of valence electrons. Therefore, all elements in group 1 have 1 valence electron, and all elements in group 2 have 2 valence electrons. Valence electrons are the outermost electrons that are available for chemical bonding and or interactions with other elements' valence electrons. This is why elements in the same group have similar chemical reactivities. The horizontal sections of the periodic table are called periods. Period 1 has 2 elements in it with hydrogen and helium. Period 2 begins with lithium and ends with neon and includes all the elements in between. All right, so I'm going to show you these 2 levels of organization on a periodic table. Okay, so let's pull out another periodic table and sketch this out here. All right, perfect. So it's the perfect periodic table, or if all periodic tables are perfect. Okay. So groups. So let's label all the groups. So this is group 1, group 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, That is the new nomenclature of this. The old nomenclature is what I was used to was this is group 1A, 1, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And then we have in the middle with the transition and intertransition elements, the 3B, 4B, 5B, 6B, 7B, the group of 8B, and 1B and 2B over there, okay? So groups are vertical columns. That means that this is a group, okay? That means that this entire vertical section is one group. Another group would be right here. This is another section and another vertical group. So everything in group 1 has one valence electron. That's why the elements in group 1 or 1A behave in a similar way. Group 2 or 2A, everything in group 2 or 2A has two valence electrons, and that's why they behave in a similar way chemically. Okay, and we can make the same case over here. These are the halogens, and these would be the halide ions. And this is group 17 or 7A, and they have 7 valence electrons, and that's why they behave in similar ways. And there are other common characteristics with each group, right? So we got the groups handled. Those are vertical columns. Now let's do the periods. So periods is the other section on the periodic table here. Well, it's it periodically, right? So periods. Periods. Okay, what are periods? Periods are the following. The periods are labeled on the left-hand side of the periodic table. There are 7 total periods. That's period 1, 2, 3, 4, 5, 6, and 7. In period 1 is hydrogen and helium. It's in the same horizontal section. In period 2 is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. In period 7 are a number of different elements. Here is period 5. So there's a total of 7 periods on the periodic table. Super simple. So we have groups or families, vertical columns, periods, horizontal sections on the periodic table. Groups or families behave in a similar way. That's why they have similar number of valence electrons and their chemical reactivities are similar. And periods do not have that same issue, or not issue, but corresponding likeness. All right, so now what we're going to do is we're going to answer some questions here at the bottom here, and we're going to figure out what we know based on what you just learned, okay? A little bit of self-advertisement here. Got to do this every single time. I am the Crazy Hat Chemist, and this is the place where you learn chemistry, and I'm hoping that you're actually learning something right here. If you're not, then uh-oh, you got to let me know. Okay, so here we go. What group is potassium located in? So we're going to pull out our periodic table here, and we are going to look at potassium, find out where potassium is. Just so happens that here is potassium. There's potassium. What group is it in? It's in group 1 or 1A. So it's in group 1 or 1A. Either one of those would be fine. All right, next question, number 2, what group is calcium located in? So calcium is right here, right adjacent to potassium. That's element number 20. It is in group 2 or 2A. So this would be group 2 or 2A. Okay, number 3, what group is boron located in? Boron is right here. That is element number 5, and that is in group 13 or 3A. So it's in group 13 or 3A. All right, what group is carbon located in? Here is carbon. Carbon is in group 14 or 4A. 14 or 4A. Fantastic. What group is nitrogen located in? That's the next element, nitrogen number 7. Nitrogen is in group 15 or 5A. That's 15 or 5A. And what group is oxygen located in for number 6? Here is oxygen element number 8. It is in group 16 or 6A. 16 or 6A. What group is fluorine located in? Fluorine is right here, right? If you're going too fast on the freeway, you're probably flooring it. Oh, little chemistry joke there. 17 or 7A is where fluorine is located in. All right. All right. And then what group is helium located in? Helium is in group 18 or 8A. That's 18 or 8A. All right. Now, the next set of questions here is going to be dealing with valence electrons. And so how many valence electrons does hydrogen have? So, well, wait, before we get to that, we're going to do one more thing here. Potassium is in group 1 or 1A, and this group has a specific name. This is called the alkali metals. Alkali metals, that's two words. Group 2 and 2A are called the alkaline earth metals. Earth metals. Okay. And group 1 and 1A has the alkali metals plus hydrogen, by the way. All right, fluorine is in a group called the halogens. And helium is in a group called the noble gases. But these lines were really trying to get you to get to the group numbering category instead. All right, so next problem here, number 9, how many valence electrons does hydrogen have? Well, let's find out what group hydrogen is in group number 1. So how many valence electrons? 1 valence electron for hydrogen. How many valence electrons does helium have? Well, helium is kind of a funny thing. I'm not sure if there are 2 valence electrons or 2 core electrons. So we're just going to put 2 right there for that. How many valence electrons does bromine have? Here is bromine, like, no way, bro. Sorry. Bromine has 7 valence electrons because it's in group 17 or 7A. So if the number is greater than 10, for certain categories, then you subtract 10 and you get 7. So this has 7 valence electrons. How many valence electrons does magnesium have? Well, magnesium is right here. It is in group 2 or 2A, so that would be 2 valence electrons. How many valence electrons does arsenic have? So arsenic is right here. It's in group 15 or 5A. So again, the number is greater than 10. Subtract 10, you get 5 valence electrons, 5A. How many valence electrons does aluminum have? Here is aluminum. It is in group 13 or 3A, and the 13 minus 10 or the 3. On the 3A, that's 3 valence electrons. How many valence electrons does silicone have? Silicone is right next to aluminum there, and it's in group 14 or 4A. And so you subtract 10 from that 14, you get the 4. That's someone who's a clown in, you know, who's a clown and not a very good person because they're a con artist, right? That's a silicon. Anyways, here we go. How many valence electrons in oxygen? Here is oxygen. We did oxygen earlier here. And it's in group 16 or 6A. So subtract 10 from that 16 and you get 6 valence electrons. How many valence electrons in xenon? Xenon is over here. That is a wonderful noble gas and it is in group 18 or 8A. And that would have 8 valence electrons. All right, fantastic. You know what? I can't believe it, but that's the end of this video. We just nailed it. So I am the Crazy Hat Chemist and you are a student of chemistry, so I'm hoping that you're enjoying this and give me a like and subscribe and share me with all your friends, and I'll see you next time. Bye for now.